Welcome back. Now we've created the temperature probe module using the temperature probe and 8-segment displays. So now let's actually draw the schematic for that so this can be more easily replicated. As you can see, I have the components that we used: the Raspberry Pi Pico, the DS18B20 temperature probe, the 8-segment displays, and everything calls it a 7-segment display, and the 74HC595s. So now, and we have ground and power and the resistor here. And so some things we need to add. We need to go ahead and add more grounds for the 74 HC595s. And yeah, we just use 2 of them for now. We can double those up. Okay. So now let's go ahead and start putting in some wires. So first thing over here, we have the ground here, and I'm going to start with the ground on the 74HC595s. Okay, connect that ground. Go ahead and connect that ground. And we're just going to go ahead and connect the grounds for those 4 chips. And then we will go ahead and connect the power. And connect the power to that chip. And go through each chip. And then stuff like this is all up to you how you want to add your wiring in. And then we'll add the power for, and also the ground for, well, the ground, there's multiple grounds, so we're gonna tie those all together and we'll worry about that shortly. So now the other thing I wanted to do here is wanted to add resistors at each of these points from the grounds from the 8-segment displays as a current limiting resistor. So I'm gonna go add those. I'm not adding a value. Well, I think it may say 1K there, or it just may say 1X. So from there, we can connect the ground pin on the common cathode pin, which is actually to ground. And we can do the same thing with each of the other pins. And if I would have lined those up better, it would have worked out a little better. But and what I am using is an online service. It's Easy EDA. It goes along with some other useful items, and you can export it. You can Yeah, you can export it to their SVG. I'm not going to try to pronounce that. And then once you create uh, you can create a PCB and the schematics for that. Okay, so with that little diversion, let's get back to connecting these pins together. And these ground and VCC are references. Um, and there's a second ground at the bottom of these chips. So it may be the top of the chip, maybe the bottom of the chip. On the module that I created, I used the bottom just to keep consistency, but they are, or at least I believe they are bonded, so either one will work. Now, let's go ahead and place another ground. Well, for each side of the chip, we'll place one ground there and another ground there, and we'll connect all the. I'm not going to connect the ADC ground. That we can do if need be, but we are not. And I missed that. Okay. And then next ground here. And one more. Okay, so all those grounds are connected, and we're going to do the same thing with the other side here. And this may be excessive. I don't know if there's enough current going through this device to warrant that, but they added these additional ground pins, so we might as well connect them all. Okay, so we got power and ground to the Pico, and let's go ahead and connect ground to the temperature probe, and then the data line has a resistor, and I'm actually going to see, I should be able to should be a way to rotate it. Okay, that's what I wanted to do. And it's still a little wide here, but this goes between data and VCC. And I missed the. For some reason, this doesn't appear to be connecting well to the data pins on here. It may just be the schematic, the pinout I grabbed. So that will probably run into a problem at some point. Okay, and let's go ahead and add another VCC here, so we're not going to go all the way over through the schematic, make things a little clearer. So this is the VCC side, and we got the VCC. And come to think of it, I am going to add a ground over here just to make things a little easier to see. and then it was this pin GP16 that will connect to the data pin. Go over here and connect there. And now we need to go through the pins for each of the chips. So okay, I already bonded, I think I already bonded those. Yeah, I did some, besides placing, I did some other work on here. So let's get a okay. So on pins 11 and 12, we want to bind those together. Those are the two, I believe it's the reset clock and the regular clock. So we're gonna bond those together on each of these. And do I have? Yep, one more. And then each of those gets bonded together. And seeing here if I have, yeah, I think the easiest way to will just be to do a full bond to all of them. So they start at pin 9 is the clock pin, which is the one right before the ground on pin 12 here. So we connect that. Let's pull it out. Up. Oops. Up. And then bond that there. And then come down here. And we'll just go along and bond each of these. And just keep connecting all of them to the associated pins. So now all the clock pins are tied together. And there's some other items that need to be connected. So output enable, which is over here, that needs to get bonded to ground or pulled low, so connected to ground. So we'll do that for each of the output enable. And the last one here. Okay. Now, I did have the reset. So now, for reset, I could put a switch. I could put I believe this is a 2-pin connector. And I think that's what I will put. So we can always add a switch or something along those lines. And the reset pin is pin 10, which is over here where it says master reset, MR. Okay. So we'll bond pin 1 on all these to master reset. And this can get tedious. I don't have a clock running on how long I've been doing this for, and I just realized I have made a mistake. I have this pin going to the clock pin going to the master reset. So that could have been a problem once we made our PCB, is having things going to the wrong pin. And go over here, back to pin 1. And now the master reset is reset low, so we're gonna tie that high. So let's throw in another VCC, so it will be probably gonna need to make this a 3-pin connection, so it's either high or low, but I'm gonna just leave it as high for right now because I don't see the 3-pin option unless I grab another connector. Okay, yeah, that's what I'll do, and pull that out, and then it could either be, okay, yeah, so this should probably be here, so I can, but that's gonna overlap. Okay, and this will be tied to ground. So that, oops, clicked on the wrong spot. Started moving the mouse before I clicked. And, okay, so that's connected there. So now the other pins, I did have the reset pin here on pin GP10, but we're going to just hold off on that for right now. And we'll go ahead and go over to GP11 and start connecting the serial input. So for each one of these, it's its own serial input. Over here on pin 14, which is labeled here as DS. So we'll go through and make the connection here to, what did I say? JP11 is the first pin. Then on the next pin, we will be going to, did that not connect? Okay, I may have messed that one up. Okay, I connected that to the wrong spot. See, can I pull that? That just deleted too much. So I'm just going to have to undo. Okay. Okay. This, I am wondering if I'm ever actually going to release this video, because I have made so many mistakes, and this is just, I'm not very sure if it's entertaining at this point or even educational. Okay, so that is, let me follow that line, that is going from DS to pin 15. Okay, so now I am going to go to pin 16 for the next one. And the third will be going to pin 17. And then we are skipping over the ground pin and going to pin 19. Okay, so we have the chips connected to the Pico and also the Pico connected to the temperature probe. And so now on the pin, we are going to, or on the chip, we are going to start connecting it to, from the 74HC 595s to the 7-segment displays. And I am going to make the assumption that this is laid out in the same manner, where this is the bottom and the decimal point is over here. And this will show how I connected the, because I was a little vague in the videos earlier, how I connected the pinout. So over here on Q0, which can also be called QA depending on your version of the chip, that connects to over here where it says pin 1. Now that is the only, okay, and I'm going to undo that because that looks like it went across the VCC. So connect there, pull out, and have to, sometimes it automates the wiring, sometimes it does not. So you have to be careful that you don't overlap any wires. So then from here, I basically just took each of the wires and continued in a clockwise direction. There was no real rhyme or reason, just went in a solid order and connected each of these pins in order. And I just did the same thing again, where I'm not pulling out far enough and causing wires to connect in bad places. So if I do create a PCB from here and I do not catch that, that is going to be pretty bad. So now the other thing with creating the PCB is, as you see, there's a lot of overlap of wires. So doing a actual manufactured PCB will, you need to make sure that you are either using enough layers or are managing your layers correctly, because you may have to orientate your wiring to accommodate, or orientate your parts to accommodate connecting it correctly. And that might involve getting maybe a different brand of chip, a different profile. We're using all through hole for this. Maybe go with a surface mount design, or surface mounted chips for some of the components. Okay, so as you can see, I connected this first chip, and I'm going to go through and connect all the rest of the chips and we will be right back after I connect all those other lines. Okay, so have everything connected. Now this design is going to, as of right now, going to assume that power is going to come from the USB port. Now that may change, may pull in a battery pack or something in a later revision. The other thing is a lot of these wires are crossing each other, so I'm going to try to, let's see, and may have to go around and for each of these change a color, but that's going to be more later on, more fine revisions. So with this schematic, even though it is a little complicated, is going to be used on my planned live live stream, which will be in August. This exact date isn't known. I'm thinking may do August 12th. I'm looking at the wrong date. August 17th, sorry. So August 17th, gonna try to do a live stream where we wire wrap this onto perf board, and we'll go from there. If you see any problems, like I just noticed right here that this line right here is crossing that should be connected to the master reset and not Q7. Yeah, so Q7 and Q7 prime are the two wires. Let me see if I can fix this. Okay. Are the should be linked together. I think that is part of the problem I was having for the decimal point. As you can see that I'm having Q7 connected to pin 8, which they actually label as the decimal point. So that is the most significant bit, and as you can see, as it goes down. So gonna make some modifications probably offline for this, but keep a lookout for the live stream on August 17th. I will probably pin a comment in this video with the exact date, and I will be posting this at some point to the GitHub, either this version or the version I correct offline with any problems I see. But you don't need to be watching me play around with individual wires. Maybe we'll do a better tutorial on this as I get better with this design software. But yeah, go ahead and subscribe so you can keep eye out for any future videos, and you have a great day.